Assalamualaikum and a very good evening to Madam Isadora binti Mustafa. So today we're gonna present our lab 4, which is Finite Impulse Response, or we call it as FIR, filter design. So my name is Muhammad Rahimi bin Ayub and my friends Muhammad Syahmi bin Zulkifli. So let's go into the procedure. Okay, for the procedure, for FIR, so for the number 1, the system impulse response vector are as follow. So for the value is given for H1, H2, H3 and H4. So the value is given like this. Okay, for the exercise, based on lab 2, plot the z-plane for the zeros and pole and the frequency response for each type, each system using the subplot function to the plot the z-plane and frequency response for better observation. And then for the B is determine the filtering characteristic of the above FIR filter. So this for the number B, Shami will explain for the at the question and discussion. Okay, C is implement all the figure above for the H1, H2, H3 as the value given in Simulink, making use of the common block such as delay, gain, and adder. Generate two sine signal using sine wave block and observe the input and output signal using scope and spectrum analyzer block. So the diagram will be like this for the C. So I will go through for the A first. Okay. Okay, this is the for the Simulink. Okay, I will show later. Okay, this is for the A. Okay, we can see here. Here is for the we just refer to the coding for the lab number 2, which is Z transform. So the coding is also likely slightly same, just the value is different. Okay, so we just copy and put here and just change for the value. So we can see here for the B, B1, B2, B3, B4. This used for the value of the at the procedure given. And then for the rest is same. Okay, I will run for this. Okay. So we can see here. Here is have a H 4H. So this for the magnitude response 1. For the second one is magnitude response 2, magnitude response H3, magnitude response for the H4. We can see here the graph is slightly like this. And for the number 2 is have a 2 like this. And for the number 3 and number 4 also with the different graph. So for the Z plane, we can see here this diagram it show like this. And for the Z plane, we can see it start from the right, from the negative. Okay. Okay, for the H2, okay, we can see here have a center of the have two have one peak and two small peak. So we can see it is a stable. Okay, we can see for the Z plane also like this have a 3 for the left and 3 for the right. So for the H3, we can see for the magnitude response graph. So we can see here the graph will be like this. Okay, for the Z plane also we can see have at the center and at the right one. Okay, for the H4, magnitude response H4, we can see here it start from the above and down to the normalized frequency and going up. So we can see for the Z plane at the top and bottom. Okay. Okay. Okay, for the second one, also same. I just do two graph, two coding. just to see the for the magnetic response only. Okay, just same as for the number one. But for the number one, I'll do for the Z plane also. Okay. Okay, go to the C. So by using the Simulink, okay, I already do. Okay, we can see here I already do into Simulink. So I will show only one, and the rest I will show at the screenshot. Okay, okay, this is the diagram. Diagram as refer to the procedure given. We can see here. Okay, at the schematic capture for the FIR filter H1. Okay, I copy like this. Okay. So for the gain number 1 is 0.1, for the gain number 2 0.4, for number 3 0.5, 0.4, for the number 4 is 0.1. Why? Because of the value given at the H1. We can see here. So we just need to insert the value into the Simulink. Okay. So I will run this Simulink. It will take time. Okay. Okay, it will show two spectrum analyzer. We can see here. The graph will be like this. Okay. For the second spectrum analyzer. Okay. The graph will be like this. At the peak at 7 something. Okay. Okay, for the 40, for the frequency 40, we can see only is a little bit peak here. Okay. For the scope, okay, for the scope one, we can see the graph will be like this. Okay, for the scope number 2, the graph will be like this. Okay. Okay, this for the H1. So for the H2 until H4, I will show into by using the screenshot. Okay, go. Okay, for the H2, you can see here. Here have a 7 gain. So we just need to insert the value. So for the first one is 1, and then 0, and negative 1.618, and then 0, and 1.618, 0, and negative 1. And the last is negative 1. So this, okay, we can see here, have also same, but the value is different. Okay, the graph will be like this. It is like slightly same at the number 1. But for the spectrum analyzer 2, is different from the H1 because of the different value. Okay, this for the time scope 1, and this for the time scope number 2. It constant. Okay. Okay, for the H3, we can see have a 4 value 0.25, negative 0.25, 0.25, negative 0.25. So I already insert into the gain 0.25, negative 0.25, 0.25, and negative 0.25. So after I run, okay, the graph also same for the spectrum analyzer 1, but for the spectrum analyzer 2, it's different. For the spectrum analyzer, for the H1, we can see at the 10, it become peak, but for the 40, it become a little bit peak. But for the H3, it different. It reverse. Okay. Okay, this for the time scope number 1 is same, and then this for the time scope number 2 is different to the others. Okay, for the lastly is H4. So we can see here have a 7 gain because of a 7 value 1.1.0, 0, 2.618, 0, 2.618, 0, 1. Also, okay, and then I just insert into the gain. So we can see here I already insert. So after I run, so for the spectrum analyzer 1, the graph will be like this. Okay, for the spectrum analyzer 2, also same. Okay, for the time scope, we can see here the graph will be like this. And for the time scope number 2 after filter, okay, the graph will be like this. It's different. It become longer, the value. Okay. Okay. Lastly, for the question and discussion, I will pass to Shahmi.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shami bin Zulkifli. Okay, in this slide 4, I'm gonna explain about the question and discussion, also the conclusion of this slide 4. Okay, for the first one, uh, determine the filtering characteristic of the above FIR filter. Okay, for the H1, H2, H3, H4 in this slide 4 that Rahimi already did, the H1 is a low pass filter and the H2 is a band pass filter, H3 is a high pass filter, and H4 is a band stop filter. Okay, the answer that I get from this because I refer to the note that were given in our lecture. Okay, for the conclusion is in the end of this practical work, we need to be familiar with the MATLAB Simulink and understand the basic concept and working principle of the FIR and IR filter. Next is to understand the structure of the FIR and IR filter. We are able to understand the concept of certain FTR and IR filter design technique to acquire the capability of designing FIR and IR filter to meet a certain filtering requirement. Lastly, we managed to complete this practical work follow the procedure given correctly. Okay, that's all for us from us in this lab 4. Thank you.